again, everyone. So we'll continue the session on series. Hopefully you have practiced a bit of the polynomial series by taking some random examples, and hopefully you have not confused yourself by trying and applying those concepts in any type of series that comes up to you. That is not for any type of series. We mentioned it beforehand. It's only for polynomial type of series where the general term of the series can be expressed as a polynomial equation. A function rather. So without spending too much time on discussing polynomial series again, let's get into some special series here. Let's first take a very easy example of that. Let's take a series as such. Now, whenever you look at a particular series, the first thing that should come to your mind are the differences. Just keep this in mind. As simple as that. Every time you look at a particular series, the first thing that should strike your mind are the differences. So let us first of all check the differences here. So if you look at the differences, it's 4, 15, then you have 67, and then it increases rapidly, right? Very rapidly it keeps on increasing. So if you just check the differences here, that's what we were mentioning earlier. So differences keeps on increasing very rapidly, isn't it? Now I can get a little bit into the types here, but let me first generalize the type of series that we are presented out here. Whenever the differences are increasing very rapidly, now this is a term that I should define at this point of time. What do I mean by very rapidly? Just look at this. Let's look at this. Compared to the previous term, what is the difference? So compared to 3, 4 is close by. Compared to 7, 15 is double. 22 to 67 is triple. 89 to 357 more than 4 times. So you keep on increasing very rapidly, right? So that is what I mean by increasing very rapidly. So whenever you have something like this, the first thing that should strike your mind is that the series, every term in the series is getting multiplied to something or the other. Now it's not just getting multiplied. It might be getting multiplied to something and getting added. There might be something happening, but there should be something getting multiplied out here. So if you look at this, 3 to 7, and this approximately doubled, isn't it? That should be the first thing that strikes your mind. But let me ask you this question: why not tripled? Why not 3 into 3 is 9 minus 2? It might just happen, right? It can be 3 into 2 plus 1. It can be 3 into 3 minus 2. So instead of taking too many trial and errors, what I recommend to do is start with the higher values here, because from 3 to 7 you might get too many multiples of 3 close to 7. 3 into 2 is close, 3 into 3 is close. Even 3 into 1 or 3 into 4 is not very far away. But if you look at this 89 and 446, I think only 89 into 5 is close by 446, right? So if I go with 89 into 5, that is 445, plus 1 gives us 446, isn't it? Now testing the previous one then. So now it is easy to check in the same way, because as this plus 1 is happening, it should be observant pretty fast. That 22 into 4 plus 1 will give us this 89. Again, if you look at this, 7 into 3 plus 1, going by the pattern, this is this, and then of course this will tell us 3 into 2 plus 1. So once I'll just break it down for you again. First thing, again the differences. as in polynomial series, you will have somewhere or the other the difference is getting constant. I mean, that is the second part. We'll come back to that later on. Just keep that thought in mind. So in polynomial series, you have that difference is getting constant somewhere or the other. But in these kind of series where the differences are increasing very rapidly, the difference is not going to get constant. So it is going to increase very rapidly, whichever level of difference you check. So in that case, the first thing that should strike your mind is, okay, so something is getting multiplied. Now, what is getting multiplied? Which multiple are we talking about? The best way to analyze that is by treating the higher values. Now, I don't mean the last terms, okay, by the higher value. It might just be that you're getting divided by something from first term to last one. I mean, the first terms are, I mean, the first two terms or three terms are higher compared to the fourth and fifth term and so on. So the series is getting divided by something. So in that case, also, I mean, check with the higher values. The higher values is what I mean to say. So in this case, I say 89 and 446. I mean, start by that, because 89 into 5 is close to 446. No other multiple of 89 is close to 446. Same thing with 22 and 89. I mean, 22 into 4 is close to 89. Nothing else is very close to 89. So once you use this idea, these kind of series would definitely be helpful. Another thing here, just in this series itself, as I was mentioning about that L1, L2, L3 difference. So if you look at these differences here, you have 4, 15, 67, then 357. Let's take the differences again. So you have 11, 15 and 67 is a difference of 52. This is a difference of 290. You observe that each level of difference, there is a huge increase from one difference to the next difference. And what I'm trying to say is, the gap between 4 and 15 and the gap between 15 and 67, it's a huge, it's almost a multiple of that. Because what is the gap between 4 and 15? This 11, right? And 15 and 67, the gap is 52. I mean, it's almost like 4 times, more than 4 times or something. I mean, same with 52 and 290. It is even further more. I mean, it's not 4 times, it's actually 6 times, I mean, close to 6 times, right? And 5 times or something. So this never a chance that these series would ever get into a constant level of difference. And I have a good example to elaborate this idea with. Let me take a basic of this series, and the very basic series of this. So let's take this series. I think most of you must have this idea, right? I mean, GP series, the very basic GP series that you can think of. Now check the differences here. 1 and 2 is a difference of 1, then you have 2, then you have 4, then you have 8, then you have 16. I'm sorry, I missed out the 32 here. Then you have 32, then you have 64. Do you observe that you get the same terms again? So just by logic, tell me this. I mean, is it possible that ever this difference would get constant? I mean, the difference is again the same terms itself. So how would the difference ever going to be constant? The same with something else. I mean, let's take up 1, 3, 9, 27, 81, 243, and powers of 3, let's say. So here, if you take the difference, is 2, 6, 18, 54, 162. Now if you check this, double of 1, double of 3, double of 9, double of 27, double of 81, again the same problem, right? So in this kind of series, it's never going to happen, right? And what are these series? You're multiplying something, right? Essentially that is the same series that we talked about previously. So please try to understand that. I mean, don't assume that somewhere or the other the differences are always going to be constant for every kind of series. Not at all. Whether they are some types of function or not, that doesn't happen that way. What I mean by functions not, so the two types of series that we have discussed till now, whether the polynomial series or these multiple types, you'll always have I mean, these can be always represented in terms of some sort of function or the other, either a recursive function or a plain arithmetic polynomial function or something like that. But it can always be represented, the nth term can always be represented in form of a function. I'm not getting too much into that in this kind, because it is not required as such. Because the only reason this is not required is you don't have to find the sum of n terms of series of these types usually. you'll always have to figure out the nth term. So not that also, I mean, maybe the next term or those kind of questions. So as in the previous example, so you'd be given 3, 7, 22, 89, 446, and just find the next term. So I'll just stop here by giving one more example. What I expect is you guys just try out this example yourself, and hopefully you'll learn a little bit to how to apply these kind of understandings into various types of series. So I'll just put this example. Just give me a minute here. So okay, just find the next one. uh, so please pause the video at this point of time and try this example yourself. Once you get the answer, you'll be more happy, after looking at the solution, if it matched. So once you have paused the video and tried the example, so here's the solution here. So again, if you find the differences are, I don't think I have to write the differences also. I mean, it's very easily observable that it is increasing at a very rapid rate. So again, starting with the higher values here. So 92 times how much is 463? Close by 5 should strike your mind. So 92 into 5 is 460, plus 3 gives us 463. Again, 15, this is 6 times, right? So 15 into 6 is 90, but then plus 2. Hopefully you can observe the pattern straight away, but if not, then I hope this much is evident. So previous should be 2 into 7, that is 14, plus 1 should give us 15. So I hope you understood this. Into 7 plus 1, into 6 plus 2, into 5 plus 3. The next one should be into 4 and plus 4. So basically the answer will be 463 into 4 plus 4. Sometimes in these kind of questions you will have only one option having a last date of 6. That will work out. And if you have to calculate, I would recommend doubling 463 twice. So that is 926, and double of it is 1848. And then I'm sorry, 926. Sorry, 926, and double of that is I'm sorry, 1856 is the answer. Okay, so that's one way to get the answer, but many times you'll find the last digit only working. And hopefully you got to understand how to tackle these kind of series. Somewhere down the line I also found examples like this. I mean, into 0.5 plus 1, then you have into 1 plus 2, then you have into 1.5 plus 3, into 2 plus 4. I mean these kind of series sometimes gets confusing to few people, because what they find is they start off with a term like 4, and then suddenly you have 3, and then you have 5, and then you have something like 10.5, and then you have 25, and then that gets confusing. So I mean, okay, what happened here? It suddenly decreased and then increased, but only thing that you have to observe is, again, that difference is increasing very rapidly, right? So even here, I mean, 3 to 5, 5 to 10.5, then 10.5 to 25, the difference is increasing very rapidly. So it's see, it has to be always a comparative understanding. So 3 to 5, there's a difference of 2, then 5 to 10.5, there is 5.5, 10.5 to 25, there's a 14.5. So that difference is increasing very rapidly, right? And more importantly, whenever you have something like this 10.5 and stuff, that's a good clue to me, at least, that this might be something close to this multiplying or something like that, because suddenly where this 0.5 comes from. So I mean, this is precisely the calculation that I used here. So 4 into 0.5 is 2, plus 1 is 3, 3 into 1 is 3, plus 2 is 5, 5 into 1.5 is 7.5, plus 3 is 10.5, 10.5 into 2 is 21, plus 4 is 25. I hope you get that the next term would be this 25 into 2.5, so that is 120, 12.5 plus 5, that is 17 point. What the hell am I doing today? 62.5 plus 5, that is 67.5. So that is the answer. So hopefully you got a good idea of how to tackle this kind of series. So we'll continue this series of series with some more videos on it, and keep on practicing on these concepts. Hopefully that would help you in these exams. Thank you.